Just if there are any spare seats at all, just moving towards the middle. Don't leave any holes. I can't see very many, but we're desperately short of space. So if there's a seat between you and the middle, move into it. And then we can get a few more people in on the edge. Thank you.
I found one.
You found one that works.
Do you like my bulge and my disc? Yeah.
Right, well, good evening, everybody. Welcome to our public open evening here at the Institute of Astronomy. It's great to see so many of you here. Hopefully the people in the Overspills can hear us, and we're also live on YouTube. It's my pleasure to introduce Charlotte Simmons, who's a postdoc at the Kavli Institute of Cosmology, just the building's behind us there, does a lot of work with the James Webb Space Telescope, and tonight we're looking at galaxies. Guess who? So, Charlotte.
Hi, thank you, Paul. So first of all, thank you so much for coming tonight. I know it's cold and it's dark, and you all made a huge effort to be here today to learn about galaxies. So I really appreciate that, and hopefully we can have lots of fun together. I have to say, I have not been sponsored by Hasbro. This is... So please do not tell them. I don't need any lawsuits. So yeah, today we're going to learn a bit about galaxies and end with a game of Guess Who. So I'll need you to pay a lot of attention when we get to the part where I teach you how each galaxy looks, okay? So the roadmap for today is that we're going to talk about galaxies. This is what I actually work on the day-to-day life. I look at the most distant galaxies in the universe and make all sorts of conclusions about them. And after tonight, maybe you'll be able to do that too. So the roadmap for today is that first we're going to talk about what is a galaxy. How did we discover galaxies? How do we know that there are galaxies out there and we're not just alone looking at a ceiling? And then how do galaxies look and how do we classify them? And when we get to this point of how do galaxies look is when I'll need you to wake up if you're sleeping so that you can pay lots of attention, because we're going to use all the knowledge you get to play a little game of Guess Who. So let's start. A galaxy is a very simple concept, actually. It's just a bunch of space, gas, and dust, loads of stars, and they're all pulled together by gravity. You might notice in this image, this is taken from the Earth, we can see part of our own galaxy up there in the sky. Does any of you know what the name of our galaxy is? Yes?
The Milky Way.
Yes, exactly, the Milky Way. But our galaxy is just one galaxy among trillions of galaxies in the universe. That's a 10 with many, many zeros after it. And this is a bit of how they look like. These are real images of the universe. In the top, I'm showing a very deep image taken with the Hubble Space Telescope. They're on the top. So this image on the top was taken about 20 years ago. The bottom one was taken with the James Webb Space Telescope that was launched 3 years ago. And you can see in both of them, it's full of galaxies. Galaxies have all sorts of shapes and colors and sizes, and it's full of them. They are everywhere. But how do we know? How do we know there are galaxies out there? Oh yeah, warning, you're going to see a lot of cats tonight. So if you get bored with the galaxies, just look at the cats. So to know how we discovered galaxies, we have to go back in time for a bit. We are going to go back to the 1700s. Yeah, so black and white cat. So in the 1700s, there was a French astronomer called Charles Messier, and he took images of all the pretty things he saw in the night sky. He found about 100 different things that looked really interesting. They either looked like groups of stars or what he called fuzzy nebula. At this point, they thought that everything that he was looking at in the sky was part of our own galaxy, and that our galaxy was the entire universe. There was nothing outside of there. Everything we saw was part of our own galaxy, and that was it. And this is how the catalog looked like. So here are these 100 objects, 110 objects, And you will notice that some of them look like just bunches of stars, but some of these you might know with your modern eyes, they look suspiciously like galaxies, don't they? Based on what we've seen of the Milky Way and things like that. And in particular, I want you to look at this one over here. Maybe someone recognizes it, but if you do, shh. This little guy over here was really important because it was due to this galaxy that we now know that there are galaxies out of there. Do you have a question?
I think that's the Milky Way.
It's almost the Milky Way, but not quite. So, based on this object here, a very clever man called Edwin Hubble calculated the distance to it and found out it was actually too far away to be part of our own galaxy. And this little person over here, which is almost the Milky Way, the reason I say that is because it's one of our sister galaxies. This is Andromeda. It's a nearby galaxy that looks very much like our own galaxy. It's basically the same size. But up to this point, people didn't know that. They thought it was a tiny thing inside of our galaxy. And so about 100 years ago, so that's not that long ago, Edwin Hubble measured the distance to this galaxy and found that this was not a fuzzy nebula, this was indeed a galaxy that was really far away. Actually, he measured it and described that it was about 700,000 light years. That's a very big number. Just to put it into context, every measurement we had of the size of our own galaxy was at most 100,000 light years across. So this was way above the number that we expected our own galaxy to be. This was the first proof that we had that there are things out there. But how did he measure the distance, you might be asking? Well, with Cepheids, of course. You've heard of them, right? Everyone has heard about Cepheids. So these are a very special kind of star that pulsates. So this little image here shows a star that's getting bigger and getting smaller. They do this in a regular interval, so they keep the beat. They're like the drummers of the universe. And they're very special because when they get bigger, as you see there, they get brighter. And when they get smaller, they get dimmer. And so Edwin Hubble looked at an image of Andromeda, which was actually this ugly one here. So it was a plate. It wasn't an image on a computer as we would use it today. And he noticed that when he imaged this galaxy, after a few days, there was one point that became brighter and dimmer and brighter and dimmer. And what's so cool about these stars in particular is that we can use them to measure distances because of a lovely female scientist that we had in the early 1900s called Henrietta Leavitt. So what she did was she studied these kind of stars and she discovered that the quicker that they pulsate, the brighter that the stars actually are. So the way that we use them to measure distances is that if we know how bright the star is and how brightly we see them, then we can estimate the distance. Just to put it into context in a down-to-earth example, if you went outside right now with a friend and your friend turned on the torch of their phone, if you're close to your friend, you know that the torch is bright, right? You can see it. But if you separate and you walk away from your friend, that light is going to look dimmer and dimmer. But you know that the torch is just as bright. It's just because that you're walking away that it looks dimmer. And so this is why we can use these stars, because we know exactly how bright they are. These are the torches. And so we know that any difference that we see in their brightness is because of their distance. And this is what Edwin Hubble used. And thanks to that, we found our first galaxy, and then that led to hundreds of thousands of galaxies more. The Hubble Space Telescope that I showed you before was named in his honor. And as I said earlier, we discovered that galaxies are just like us. This is why I love studying galaxies. They come in all sizes, in all colors, in all shapes. They have all sorts of properties, and they're very much like the snowflakes of the universe. They're all different. And since they're all different and all interesting, we had to find a way to classify them, because that's what we do. And this is where, if you fell asleep at this point, I needed to wake up, because I'm going to show you how galaxies are classified. So hopefully this woke you up. So we have two ways of classifying galaxies. We either identify them by the shape, which, as you see here, just like cats, galaxies have all sorts of shapes, or we can classify them by their properties. For example, if they're forming lots of stars, I would associate it with a cat that looks like that. So that's why it makes sense. So we're going to go over 7 classifications, and hopefully you will remember all of them because we're going to use these to play Guess Who in a bit. Okay, so it's 7 of them. So first we're going to classify them by shape. The first shape that we're going to look at is spiral galaxies. You've probably seen loads of galaxies like this. This is probably the idea that you have of a galaxy when someone says, imagine a galaxy. Well, what identifies a spiral shape, I made some props today in my office. So you will notice they're very professional. So what identifies a spiral galaxy is that it has a bulge. I didn't have balls, so I had to be creative. We have a tiny orange. In this central bulge, which is either spherical or ellipsoid, you have all stars. And around this, we have a disk of gas and dust. And very especially, it has spiral arms around it that are winding. And on these spiral arms, we're forming stars. So this is a spiral galaxy. We can see it like this. We can see it like sideways. We can see it in all kinds of ways, but this is what identifies a spiral galaxy. So we have type 1, okay, spirals. Now, if the central bulge is not circular anymore, and it's more like a rectangle, I didn't get a rectangular orange, couldn't find them, so you have to imagine it, we would get a barred spiral. So this is also a galaxy that has spiral arms, but the center is not a sphere anymore, it's a bar. Our own Milky Way looks like this. And actually 2/3 of every galaxy that we see that it has spiral arms has a bar just like this. We believe this is part of the lifetime of a galaxy. They eventually go through this phase. Yes. Yes, everything is spinning around the center, so it's a flat disk and everything is spinning. Yeah, everything in the universe spins quite a bit. It's the only thing you can trust in the universe. Okay, we have normal spirals that have a circular bulge, and then we have barred spirals that have a bar in the center. Okay, we've got 2 types. The third type is, imagine we had this galaxy, but we don't anymore have the disk. We just have the bulge. So we just have the central part that has lost all its gas already. It formed all its stars. So it's just now old stars that are basically dying. So these are red, big blobs, and actually they're usually bigger, so they're not a tiny orange anymore, they're more like a grapefruit. So this would be your elliptical galaxy. And it's a bit difficult to see with the light on, but you would usually see that they're kind of reddish. You will see a well-defined red blob. So we have 3 types. Let's go to the next. The next is, imagine what would happen if we combined an elliptical and a spiral. So this means we still have a bulge and we have a disk, but now this disk is not forming stars. So it's the other side. So this would be a lenticular. So it's a bit like a mix in between where you're not forming young stars anymore, but we still have the shape of the disk. We just don't have the arms of the spirals. And if you look at them sideways, they kind of look like a lentil, which is why I think they're called lenticulars. So that was a 4th type. Now the 5th one is quite easy. These are just the ones that we don't know what to call because they don't look like anything. These are irregular galaxies, so you'll notice that there's no defined shape. This one looks more or less circular, but you'll notice it's just like a bunch of stars. It doesn't have this red, huey, elliptical shape that we saw before. So these are just galaxies that probably went through interactions with other galaxies and that just disrupted them and left a mess behind that now we see and we don't know how to classify. These are not. They basically have movements going everywhere. So they don't have a defined movement, and that's why they don't really have much of a structure. So these were our 5 classifications by shape, and now I'm going to add 2 that are due to the properties. The first one is an active galaxy. Active galaxies are galaxies in which the central supermassive black hole, which I didn't tell you, but every massive galaxy has in its center a supermassive black hole. And when material is falling in and the black hole is feeding, we say that the galaxy is active. Now, the more extreme cases of active galaxies look like this. Not all of them do, but the most extreme cases where the black hole is feeding so much look like this. So basically what's happening is that you have your black hole, Black holes don't emit light, you might know that. But when material falls in, as it gets closer, it starts to spin quicker and quicker. And as it starts spinning quicker and quicker as it falls in, it heats up lots. And that emits a lot of energy and a lot of light. And that's basically what you see here. They become so powerful that they create these huge magnetic fields around the central black hole, and they eventually just shoot out material. So this galaxy that you're seeing here on the left, the galaxy is actually sideways, so we have like a disk like this, and then these jets that you see coming out of there are coming from the black hole. Yes?
The one that has the thing on it.
Yeah?
Is the reason why the thing starts because the black hole starts to mid? Like the center.
No, the ones that you see here, which that's an interesting hypothesis, they just look very small. So the galaxies look so small compared to the jets that you don't really see the features of the galaxies. But it's more a scale thing. These jets are huge. So the globes that you see here are the jets coming out of the black hole. Yeah, so I just want to remind you that not every galaxy that's active looks like this. These are the most extreme, but it's the ones we're going to use for Guess Who because it's easy to see them. Everything that's being funneled into the black hole, so anything that's falling into the accretion disk, so just gas and dust and anything that's around the black hole in the galaxy. And then finally, these are also quite easy to see, interacting galaxies. So this means that two or more galaxies were interacting, and they lead to all sorts of shapes, as you can see here. So when two galaxies interact, there's several things that can happen. You can either end up merging and creating this super mega galaxy, which is what is going to happen to us and Andromeda in about a few billion years from now. We're going to merge and become one mega galaxy. But in other cases, galaxies interact, and what they do is that they don't actually crash and merge, but they just go around each other. You know, they just go by like, hey, I'll steal some gas from you. So they just move the gas and material around, and that leads to all these weird shapes. And my favorite here is called a jellyfish galaxy. This is the actual name. And it's due to two galaxies interacting in such a way that one pulled gas from the other, and stars are being born in what would be like the tentacles of the jellyfish. So we have all these weird shapes that come from when galaxies interact. So we saw 7 different shapes. Do you think you're experts? Yeah? Okay. Yes?
What's that purpley blue part?
The purpley blue part, this is most likely a nebula, which is where stars are being born inside of our galaxy. Okay, we're going to play a little game of Guess Who. This is going to work a bit differently to any other game of Guess Who that you've ever played, just because I had to make it work with slides. So the way it's going to work is that I have 15 galaxies here. They're all numbered. And I'm going to give you clues. And every time I give you a clue, you're going to tell me which numbers we shut off, okay? Until we find the final galaxy, which is a galaxy that I am thinking about. Are you ready? So the first clue, the galaxy is not an elliptical galaxy. Do you remember what an elliptical galaxy is? So we had the bulge, but we didn't have the disk, and we had this red, like, blobby structure, okay? So which ones are we removing? Yes? 7, I hear 7. 1, you over there? 9? 9 maybe. So 9 looks very similar to an elliptical, but you'll notice it doesn't have, it's hard to see on this screen, I guess. It doesn't have the red hue around it. We'll take one more, you? Number 3. Number 3 is not quite an elliptical, but I did hear number 1 and number 7. That's everyone that agrees at number 1 and number 7. Raise your hand. Okay, I agree too. So that's exactly what it was. Okay, next clue. The galaxy is not active. So remember when I showed you the big jets coming out of a galaxy that come from supermassive black holes? Which one are we taking off here? Just say it, because otherwise... 6. Okay. Who says 9? Okay, who says 6? Okay, 6 seems to be overwhelming majority, and 6 would be correct.
Yes.
So the next clue. The galaxy does not have bars. You're going to have to look very closely because some of these are a little bit small, okay? So which galaxies are we getting rid of that might have bars? 8. Okay, let's do something. I'll say a number and we vote. Okay? Who says number 3? Okay, not much for number 3. Who says number 2? Well, no, not much. Okay, number 4? 4, yeah, 4 is one of them. Number 10? Does anyone see a bar there? Yeah, I kind of see a little bar there, yeah. Number 11? No, number 11 seems to be 2 galaxies, right? 13? I have to say, it looks a lot better on my screen than yours. So if you squint, there's a tiny bar in 13. And 14? No. 15? Yes. Okay, so we have 4 galaxies that have bars. We have number 4, 10, 13, and 15, and we're cutting them off. Next clue. The galaxy is not a spiral. So remember spiral, the beautiful props? We have a disk with arms and a bulge. So which one is a spiral? Yeah? Yeah, okay. Okay, I think everyone recognizes the spirals. Okay. 3? 3? Yeah? Yes. This one is a trickier one, I guess. The galaxy is not irregular. So remember, irregulars just have like random shapes. They don't really look like anything in particular. Which one is 9? Okay. 9 and 2? 2 and 9. Yeah? Yes. And the final clue, which if you're following, you might figure out which the next clue is, the galaxy is not interacting. So, yes? Yeah? Okay, so let me phrase the question differently. Which is the only galaxy that is not interacting in this picture? 8. Exactly. And can you tell me what kind of galaxy that is? Lenticular. Yes, I don't know who said it, but well done. You found the lenticular galaxy. So, thank you so much for playing this with me. If you really liked looking at galaxies tonight, the collaboration that I'm part of is called JADES. We work with the James Webb Space Telescope, and we have access to the deepest images of the universe up to date, and we have made a lot of them public. So if you would like to see galaxies on your own free time, here is a link and a QR code that will take you to our viewer that looks like this. And if you zoom in, you can look at galaxies for hours and for days and classify them and make your own Guess Who games. Maybe send them by email to me if you make a better version than I did. And if, I'll let you take pictures of that. So while you do that, I'll just thank you so much again for coming. We do have a real game of Guess Who Galaxy Edition out there in the coffee break if you want to play with your friends. And if not, I'll take any questions you have, and thank you so much for coming tonight.
I've got a question.
Oh, no.
Are those all your cats?
No.
Oh. Has anybody got a question for Charlotte? Hand up. Yes, one here.
I know what the stars are when they die.
Mm.
Black holes.
Some of them are, yes, that's very clever. So the most massive stars die in the most dramatic fashion, and they end up being supernovas, which are these huge explosions, and some of those turn into black holes. Yes.
Okay, we've got lots more hands up. There's a boy here.
Yeah.
Shh. In supermassive black holes, what
Yeah. That is a really cool idea, and I think there's a lot of sci-fi that's been put in our heads. Unfortunately, black holes do not suck things in as we usually think about them. Things just fall in. So the black holes, as massive as they are, they only have an influence of things that are very close by. So if you get close to a black hole, it will eat you. But if you stay away, there's nothing it can do to you.
Sorry, there's one up there in the pink.
All the water you drink is 13.8 billion years old.
Oh,
Is that right?
I don't think so. Well, the age of the universe is about 14 billion years old, so that is true. I really hope my water is not that old.
One down here at the front. Who's next?
Why do like galaxies and space fail not?
This is because the universe, everything is moving a bit like either away or far or towards something, right? And as things start to form around, for example, supermassive black holes that start to, anything that falls into it, it's just a natural way when things are already moving that they end up moving in a circle around it. This is how you will see that galaxies form as disks. You also notice that when you have planetary systems like our own, our solar system, all the planets are moving around the sun like this. It's just a natural, most easy way for things to form when they fall, coming from a different place in space.
There are more hands up than I can cope with here, but I think you were next.
I know we have two black holes in our Milky Way. What are the names of them? The big one and the smaller one.
So we actually have lots of black holes in the Milky Way. The supermassive black holes, we have one that's Sagittarius A, I believe its name is, which is in the center of the galaxy, but that is the supermassive one. And then we might have lots of ones that are when stars die. So those are smaller black holes that live in the galaxy. So the biggest one is Sagittarius A. Then the smaller, the smaller black holes that are formed by stars, we don't really name them all, so I wouldn't know.
Right at the back with the glasses. You'll have to shout.
How do the galaxies get all their gas anyway?
So the way that they get this, there's two ways. So I showed you interacting galaxies. So when one passes around the other, it just drags gas away from the other. That's one way. The other way, when the ellipticals I showed you, and I told you they were like dead and red and no more gas, that's because they used up all the gas to form stars, because that's where stars come from. So when enough time has passed, all the gas that was in the galaxy was already used to form stars. And then unless something happens, there's no more gas and they just run out.
We'll have one at the front here.
How fast the galaxies spin?
I do not know. That's a very good question, and I would have to Google it to answer you.
Boy at the back in the blue.
What happens if you got sucked into a black hole?
Well, you're not going to get out for sure.
Do you pull apart?
You would be pulled apart. So I don't know if you've heard the term spaghettification. Yeah, it's a very fancy term to mean that if you get too close, you'll be pulled apart like a human spaghetti.
Where should we go next? We've got loads of hands up. You right at the back. You'll really have to shout.
Sorry, can you say it again?
The stars and the planets like move.
Do the stars and the planets move? Yes, everything moves. Everything is moving.
This one.
The galaxies in the same classification that different still because they're different. Or do they work the same as their counterparts?
Oh, that's a very good question, and it's a question that has created a lot of debate in the past years. So all this classification I showed you based on shape was done with galaxies that were very close to us. And now that we have access to galaxies that are further away with instruments like the James Webb Space Telescope, we still see these shapes, but we don't think that they necessarily mean they were made in the same way. So they might look the same, but it doesn't mean that the same thing is happening.
Okay, I'm going to break with tradition and take an old person.
I'm sure everyone in here knows the answer to this but me. At the start you said that they measured, I can't remember which one it was, but 700,000
Yeah.
light years. Can you tell me what a light year is?
So a light year is how much distance light can travel in a year. So light travels really quickly, very, very quickly. So if light could travel for a year, that would be the distance. It's a lot. So just for reference, the sun takes about 8 minutes, the light from the sun to reach us here on Earth. So imagine a year of that.
You want a number? It's 10 trillion kilometres.
Oh, thank you.
Right at the back in the pink with a headband on.
Is it true that if you get sucked into a black hole, like you are thinner than a piece of hair?
Well, yeah, you would be spaghettified into infinity and then pulled apart. So maybe at some point of your spaghettification, you would be a very thin noodle.
Where would you like to go now? There's so many more. How many more do you want to do? Three
He
or
has
four
had
more?
his hand out for a while.
one
Yeah,
here?
yeah, with the teal.
You in the blue there? In the back?
Could a black hole actually turn dark or red?
Sorry, can you?
Could a black hole ever lead to a dark or red
A breaking point. What do you mean by a breaking point?
where, let's say, explodes like stars?
So there's something called Hawking radiation, which is supposed to be how black holes basically fade after years. They lose energy. I don't think we've actually observed that, but it's theoretically out there. It's not something we've seen.
If we'd seen it, Stephen Hawking would have got the Nobel Prize.
Yes.
But he passed away. We'll take two more. Who wants to stick your hand up high if you want to do it? You've had one. You've had one. We'll take somebody else. The orange at the back there.
Galaxy has the biggest black hole.
Oh, there was. I don't remember the name. No, I don't remember the name. Sorry, but the biggest black holes that we know of have about the mass of the Earth, but multiplied, like add 10 zeros to that. So it's a lot. Or not the mass of the Earth, the mass of the sun. So like imagine 10 to the 10 times the sun. They're super, super massive.
Okay, well, we probably can ask some more outside, but there's just one more at the front here.
What happens if a black hole eats a galaxy?
So they don't tend to eat the galaxy, they're at the center of the galaxy. So they are, as massive as they are, they're not that big compared to the sizes of the galaxy. So they would be in this picture that I showed you of the spiral and the bulge, they would be somewhere here in the middle of the bulge. So they will eat the material that's around it, but they will not eat the entire galaxy because they just can't, things have to fall into them. And for things to fall into the black hole, they have to be close. So thankfully, black holes are not gonna eat us. So you can sleep easily at night.
Okay, well, I'm sure Charlotte will be around outside. You've got this game which you set up over the far side.
Yes.
There's juice on the mezzanine for the youngsters. There's tea and coffee. There's biscuits. I'm sure you'll find the biscuits. I know what you like. So just join me in thanking Charlotte for a superb talk. let's start. Going to be full. I thought we had everybody for a minute there.
It just says how long this portion of the evening
28 minutes once I get started. And a few seconds. I tested it.
Can we sit right at the top so then we've got
Go find a seat. Yeah, no problem. Oh, we'll wait a couple. You can always get in up the back, and there's plenty of room because quite a few people have gone home. So. I'm going to start in about 1 minute. It's a really good way of cutting your fingers off. Okay, I'm going to put the lights down for this section. So let's try randomly pressing buttons and see what we get. That's not the one. That's not the, oh, that's better. That'll do. Welcome back in for part 2, everybody. It's nice to see so many of you in here. My name is Paul Fellows and I run the Cambridge Astronomical Association. And I've been doing that for quite a long time, 20 odd years or so. And I'm ably assisted by Tim and Stacey and Sebastian and a couple of other people that were here to operate the telescopes, but they've gone home because it's cloudy. So I'm afraid you're stuck with me this evening. And what I've done for you is used some software called Stellarium. I've written it in big letters on the board here to create a bit of a planetarium show. But before I forget, if you're interested in coming along on Friday, we have a meeting here at 8 o'clock with an external speaker coming in to talk about all things related to Stonehenge and how that relates to astronomy. And then for the youngsters, the 7 to 11-year-olds approximately, on Saturday morning at 10 till noon, we have a meeting here all about hunting for alien planets. So if you're interested in that, bring us your children. You know how it works.
But make sure you're here before 10 a.m.
She's very stern.
I am very strict.
They've gone up the back way. I saw them. It's like one of those. Right, anyway, so I can't take any questions as we go through this because it's all operated by one finger. I press the button, it goes, and I'm going to take you through it. But if you want to catch me afterwards and ask any questions, that'd be great. So here we go. What I've done is set it up so that it is set for today. And at the moment, it's the middle of the afternoon. We've got the sun in the sky. And of course, there's a magic button on here that lets me turn all the clouds off, which is just what you need for all of this. So now I'm going to let time run forward at high speed and of course follow the sun round as it heads down towards the horizon over here. We get the colours beginning to creep in. The blue sky starts to change to yellow and then orange. We get the colours of sunset. And I'm just going to let the sun go down and stop just as it's disappeared. So stop about now. There we are. And what we'll go and look at is just in the twilight, the first planet on our tour. This was easier to spot earlier in the month because it wasn't so much buried in the light near the sun. It's getting too close to the sun. This is the planet Saturn, the ringed planet. And it has a family of moons. When you look at it through an amateur telescope, it looks like this, except the moons aren't labelled. That's something you have to check yourself. But at the moment, you can see how the rings are almost edge on to us. And on the 23rd of March, they will be absolutely edge on from the line of sight of the Earth as the orientation of the planets wobbles backwards and forwards. And we won't see them. It'll be very peculiar. You'll just see the disk of the planet because they're so thin that at that distance, just for a few days, we won't be able to see them at all. It has a whole family of moons. This one is very famous. This is Titan. We thought once it was the largest moon in the solar system. It's actually second, but it has a very thick atmosphere full of orange smog. Very frustrating from an astronomer's point of view because we can't see through it to the ground. But a few years ago, the Cassini mission took a probe, the Huygens probe, and dropped it in there. So we began to learn more about it. Fascinating little world in its own right. Very, very cold, of course, 1 billion miles from the sun. So what we're going to now do is move on and swing round and let the sky go a bit darker so that time moves forward and we get into the proper beginnings of night. So this is a view of the whole of the sky as if you were lying on your back looking upwards, and you can see several of the bright objects there. Those are the bright planets. These are some of the constellations we're going to visit: Andromeda, Pisces, Aries, Pisces and Aries there, Taurus. These are constellations of the zodiac, and that's where the planets live. Look, you can see the bright planets are in those constellations: Gemini, Cancer, and last on our tour tonight, we're going to look at Leo there. All nicely in a line. Now, you've probably heard about this planetary alignment. The planets are always in a line, okay? Somewhere on the sky, just happen to all be in this quarter of the sky at the moment. And of course, no tour of the night sky would be complete without Ursa Major, the Great Bear, and Ursa Minor. And that orange line, that is the plane of our solar system projected onto the sky. It's called the ecliptic. We'll see that in a minute. But we're going to look first, as we should do, at the Great Bear. This is Ursa Major. That's the stick diagram. We can replace that with some artwork to show you how it makes a bear. It kind of works. You can see the familiar pattern of bright stars there, the saucepan handle, the plough. It has lots of different names, the Big Dipper. But we're going to dive in onto the middle star of the tail of the bear, which is actually double. And you can see both components, Alcor and Mizar, just with the ordinary naked eye. But if you zoom in with a telescope, and we're going to zoom in on Mizar here, you get right up close, it soon reveals that Mizar is in fact 2 stars. And we could do that for Alcor as well. And this is a pair of stars and another pair of stars going around each other and all going around together. So this is a quadruple star system. Our sun is quite unusual in that it's on its own. It doesn't have another star as a companion. Just off the tail of the bear, we've got the first of our galaxies. You heard about galaxies from Charlotte. This is the Pinwheel Galaxy, a nice face-on spiral galaxy with those older stars in the center. And where new stars are being born, you get new big stars that glow blue in the outer regions. And so we can see that in the spiral arms of the Pinwheel Galaxy. That's just to the left of the tail of the bear. If we go over to the right of the tail of the bear, we can find another galaxy, and this one is called the Whirlpool Galaxy. It was the first one to be noticed to have a spiral structure. And here it is in detail again with that same arrangement of the spiral arms, but this one is undergoing a collision. It's actually eating its smaller neighbor. This is how galaxies get big, is by devouring smaller ones. That little one has come too close, and the gravity of the big galaxy is pulling it in and will gobble it all up. So that's the Whirlpool Galaxy. Those are either side of the tail of the Great Bear. We're now going to swing across and see something very different. This is what happens to ordinary small stars like the Sun. They puff off their outer layers in what's called a planetary nebula. It's got nothing to do with planets, it just looked a bit blob-like in old telescopes. But it's a dying star. There's the dead nuclear core in the centre and the atmosphere expanding away. Our sun will do that, but we've got about another 5,000 million years before our sun runs out of fuel. So we're all right. Just above that is a galaxy. This one's a long way away. This one's 45 million light years away, and it's a little bit tilted, a little bit more edge on, but it is supposed to be a spiral galaxy. You can just about see that, and you can see a lot of those sort of dark dust lanes again that Charlotte was talking about earlier. So that's the Surfboard Galaxy there. And if we then take a trip north from the 2 diagonal stars of the body of the Great Bear, so you take the 2 stars here and you move up, then we find a little group of galaxies. There are actually 4 in this image. You can just about see them. There's the big one in the middle. That's called Bode's Galaxy. It's a really nice spiral galaxy, nearly face on. And then there's 2 smaller ones, and there's one that looks very red. And we're going to have a little bit look closer at that one. That's called the Cigar Galaxy, and that's one of these active galaxies that is chucking out huge amounts of hydrogen gas. And the reason it's doing so is that 6 million years ago, it nearly collided with Bode's Galaxy, and all the disruption and chaos that you see going on there was caused by that near collision. Those are very close to each other in space, about 10.5 million light years away. I truck these million light year figures off, you get used to it eventually. Now, if we go from the Great Bear to the Little Bear, we've got that in the middle of the screen there now. There's the stick diagram, very similar sort of miniature version of the saucepan or the plough. And if we put the artwork on, there's the Little Bear. Bears don't have long tails though, do they? I think the people who made this up had probably never seen a real bear. It's a bit wrong. Right at the tip of the tail of the bear though is this star. This is Polaris, the pole star or the North Star. It sits just at the moment, just directly lined up with the North Pole. So if you stood on the North Pole, it would be right above your head. And if you watched it closely over a long period of time throughout the day, up there in the polar night, you would see this. You would see Polaris staying still in the center and the whole sky seeming to rotate around it. Of course, what's really happening is we are spinning the other way underneath, going round once a day. And so you can tell that that star is always north of you because it always stays in the same place in the sky. Very useful for navigation. What I've done now is turn time so it's running backwards on the clock, because I want it all back where I started, otherwise I get very confused because things start becoming upside down. So we're going to go back to where we were, but you get the idea. That star is also one of those Cepheid variables that Charlotte was talking about that act as a cosmic signpost for distance. And so it's very useful for astronomers in that way as well. So a very, very important star. But it's not a particularly bright one. People think the North Star must be some immensely bright thing in the sky, but actually it looks quite ordinary to the eye. So it's often overlooked. But you can always see it if you're in the Northern Hemisphere. So that's the Great Bear and the Little Bear. What we're going to do now is move onwards, and we'll go over back to have a look at another planet. At the moment, Venus is incredibly bright in the sky for a couple of hours after sunset. If you look at it through a telescope, and we had telescopes out on the lawn on Monday, and I saw it just like this, looking like a sort of crescent moon. It's so bright because it's near to us, it's near the sun, so it gets a lot of light that it bounces off in our direction, and the clouds are very, very shiny. The atmosphere of Venus is 100 times as much as our own, and so with a lot of clouds there, it's very, very shiny indeed. Makes it incredibly bright. And sometimes it can be so bright it casts shadows. If you're out in the countryside away from all the city lights, you can often see that. So amazing, and it causes people to phone up and say they've seen a UFO quite often as well. So important to have that in the talk. So Saturn just at the bottom there next to the orange line, Venus a little bit further up. And that orange line, that's the flat plane of our solar system across the sky. So if you find a bright object close to that line through the sky, it might be a planet. Now I'm letting time run further forward. Saturn has disappeared below the horizon. Venus is heading down to the horizon there and disappearing. And we're going to move up over here to a constellation called Andromeda. And you heard about that from Charlotte too. The Andromeda constellation is that strange stick-like thing, which is supposed to be a young lady. And here she is, and she's upside down because lots of things in astronomy are upside down. But she's sort of been chained to the rock. There's a whole legend about her mother, and Perseus, the hero, comes to rescue her. But the famous thing about Andromeda is the Andromeda Galaxy just here. This is absolutely magnificent, especially through binoculars. On the sky, that's about 5 times as big as the full moon. So a telescope tends to just show you the central little bit. You want to use binoculars to look at this because it's so huge. Great big spiral galaxy, 2.5 million light years away. And it's got a couple of little friends. This is a small galaxy, doesn't have a name. It's just called M32, M from Charles Messier that Charlotte also mentioned. And that's a little galaxy right in the center of the screen that orbits round Andromeda. And this is another one, also with no name, M110, a slightly larger galaxy a little bit further away. We have some galaxies that orbit round our Milky Way. We have the Large and Small Magellanic Clouds, visible from the southern hemisphere, and a few others as well. And all of the Andromeda and its friends are coming towards us, and in about 5,000 million years' time, they will merge with the Milky Way, along with this guy. This is the Triangulum galaxy. It's the third and smallest member of our little trio. And this one's about 1/10 of the mass of the Milky Way or Andromeda, so it's relatively small, little tiny bit further away. Andromeda's 2.5. This is 3 million light years. But they're all coming together, pulled in by gravity. I don't know what we're going to call it. Milkdromeda, perhaps? Who knows? That's if anyone's still around in 5,000 million years' time, which by coincidence is when the sun runs out of fuel and blows up. So, you know, it's a bad day for planet Earth. We've also got another galaxy in Andromeda. This one's called the Outer Limits Galaxy. It's a bit further away, 27, so 10 times further than Andromeda. And it's a spiral galaxy, but it's edge on. And I like to tell people that galaxies are a bit like 2 fried eggs back to back. You have that bulge in the middle where the yolks would be and the whites where the spiral arms are. And you can really see that in that one because it's so edge on with that dust lane going through the middle. cutting it in half. So it was the Outer Limits galaxy. So we're going to pull back a little bit. You can see a little bit of the Milky Way passing across the screen there, that sort of faint band of stars. But we're going to look at some bright objects, and the next port of call is over here. It's in the constellation of Taurus, and it's the king of the planets, Jupiter. Again, we looked at this the other night. We could see it like this, with the planet itself, the two dark belts across the middle, and the 4 moons that Galileo first spotted 400 years ago. 2 of them are the same size as our moon. 2 of them are almost planet-sized in their own right. If we zoom right in on Jupiter, you see a lot more detail. You see lots of swirls and little white storms that are little hurricanes in the atmosphere of Jupiter. It's 10 times the diameter of the Earth, and it spins in 10 hours. So 10 times that way, 10 times that way, 10 times that way. You could drop 1,000 Earths inside it. It just, all the numbers get very extreme. This is one of its first moons, Io, and all of what you can see there, it looks like a pizza, doesn't it? But it's not made of cheese. That is in fact sulfur in 4 different forms: black, orange, yellow, and white, depending on the temperature. This is the most volcanic place we know. It's turning itself inside out with enormous numbers of volcanoes. The second moon out is Europa, completely different, very shiny, covered in white layer of ice, and with these dark brown grooves across it, which we think is organic matter coming up from inside, where there is a liquid ocean underneath the ice that has more water than all the oceans on the Earth. So number 1 target in the solar system to go and look for some sort of alien life. The next moon out, Ganymede. This is bigger. It's the biggest moon in the solar system, in fact. And again, a lot of water ice, probably some liquid water oceans underneath. And we're sending lots of space missions out there to try and study these moons in more detail. So those are the 3 that were on the right-hand side of Jupiter. Over here on the left, we've got poor old Callisto, the 4th of the big moons. And it's a long way from Jupiter, and it's minding its own business, and it's cold and inactive. And so it's accumulated lots and lots of impact craters from space rocks hitting it, peppering the surface there. So completely different story for that one. So that's Jupiter. And we'll pull back again. You can see lots of bright stars in the sky there. And we're going to zoom in on the constellation that's in the center of the screen. That's Taurus, Taurus the bull. The V shape is supposed to be the face of the bull. He's got the most enormous long horns up there. And you'll see the graphic here. He's got 2 front legs and no hind quarters. I don't know what happened to those. They put Aries there instead. Never mind. So the bright orange star there is Aldebaran, the red eye of the bull, sitting in front of a star cluster called the Hyades, which is the rest of the stars in that group. And on the back of the bull, you have the 7 sisters, the Pleiades, a lovely object to look at with binoculars. You can see with the naked eye 6, 7, maybe 8 stars here. I used to be able to see more. My eyes have faded a bit. But with binoculars, you'll see 50, and with a telescope, you'll see 500. There's about 1,500 altogether that we know about in that cluster that was born about 75 million years ago. So the dinosaurs were around when those stars were made. It's quite amazing that they're that old. Over by one of the horns of Taurus, we've got a star that blew up. This was a supernova explosion. A giant star exploded at the end of its life, and this is the explosion remnant still expanding out into space. This was spotted in the year 1054 by the Chinese, the Japanese, even the North American Indians did rock art paintings of seeing this event. It's quite amazing, seen all over the world. So that's called the Crab Nebula, and very interesting object in its own right. There's lots of interesting colours in there that tell us what it's made of, what the different elements that the star has made inside the pressure cooker, the nuclear pressure cooker inside the centre of the star that then exploded and scattered the material all over the cosmos. That'll get recycled into new generations of stars and planets. So we're going to move forward now to midnight. That just brings some of the other objects I want to show you into the best position. So you can see Taurus is disappearing now towards the horizon there. And we're going to go up here and have a look at the red planet Mars. Mars, very prominent, part of the parade of planets that's going on. We were looking at this the other night. It's always a little bit disappointing through a telescope because it's quite a small planet. And so it's relatively difficult to get a good picture of it. It's got two moons, Deimos and Phobos. Those are fear and terror, Mars being the god of war. It makes sense. And you can already see on the image of Mars in the middle there that we see the red dust of the desert floor, some darker highland regions, and the polar caps made of frozen water and frozen carbon dioxide. Mars is at a very low temperature, it's further away from the sun, and it doesn't have very much atmosphere to keep it warm. If Venus is 100 times more, Mars is 100 times less than that of the Earth. But very interesting planet in its own right, and entirely inhabited by robots, of course. So that's Mars. Coming down here, just on the horizon at midnight, the last chance really to take a good look at my favourite constellation of all, Orion the Hunter. Everybody knows Orion with Orion's belt, those 3 stars in a row. There's Orion facing off against his enemy, Taurus the Bull. All part of the legend that he was sent up into the heavens to face off against Taurus. But the top left-hand corner star, Betelgeuse or Betelgeuse, is one of those giant stars that's likely to explode soon. It's a red giant star, and it could be tomorrow or it could be in 1 million years' time. But every clear night I go out and check just in case, because that would be really spectacular if that blew up. It's far enough away that it wouldn't be dangerous, but it's very spectacular. If that did blow up on a Wednesday night one time, that would be good. Sorry, I think someone's trying to get in here. This is the Orion Nebula. This is stars being made. It's a stellar nursery. There's a cloud of gas and dust that's collapsed, and the materials got together in the centre, made new stars, and some of those have lit up really bright, and they're now blowing away the rest of the material. It's a self-limiting process. You get a burst of star forming, then the stars push the rest of the gas away with their heat and radiation, and so no more stars can be formed until that gas manages to escape and go and cool down somewhere else and get back together and form another group. So it's a very sort of complicated cosmic recycling process. But that's the Orion Nebula. And then up here at the left-hand end of Orion's belt, we have the really bright star, Alnitak. It's a blue giant star, very, very powerful. It's putting out lots of strong radiation, and that radiation is lighting up all that red hydrogen gas there. And there's a dirty, dark finger of gas coming in front of it. That's called the Horsehead Nebula. I always think it looks more like a seahorse. And just above the star, the Flame Nebula. But if we move on up, away from Orion's belt, a little bit higher up, there's another different cloud of gas and dust. This one's bright blue, but it's not that the gas is glowing as in like in a fluorescent tube. It's just reflecting the blue light of a star that we can't see. The star is hiding behind that big clump of dirty, dusty material in the middle there, and the blue light from it is bouncing back to us. So it's a different kind of process. There's so much more in Orion. It's full of all sorts of interesting objects, but I just don't have time. We'll be here till dawn if I carried on talking about them. We're going to move on, and we'll have a little look at a couple of the other constellations, one of which is Cancer the Crab, and it's a very faint constellation. It's got no bright stars in it at all. It was really the gap between the two constellations, Gemini and Leo, but there's Cancer, and I defy anyone to make a crab out of that. When you zoom in a little bit, though, you do see a nice little sort of four-sided grouping of roughly equal stars, and in the middle, a lovely little star cluster called the Beehive. All these look like little bees orbiting around a centre. I mean, they stay still from our point of view because we just don't live long enough, but they are all whizzing around. And it's quite an old star cluster, so there are no truly bright stars in there because in astronomy, big stars, bright stars, live fast and die young. So you get a pulse of stars forming, and then after 10 million years, all the bright ones have burnt out, leaving you the next class of stars. And after 100 million years, they all burn out, and you just end up with the faint ones left. That's why the middle of galaxies don't form any new stars, and when you look at them, they tend to be just full of old, long-lived stars instead. All the big, powerful ones have gone. Quick look at the constellation of Gemini between Orion, Taurus and Cancer there. You can see this one. These are the heavenly twins, and there they are holding hands. Look, it makes sense. There's one that does look like what it's supposed to. There they are, the two twins, Castor and Pollux. Castor on the right, Pollux on the left. And the bright reddish thing in the middle there, that's Mars, which we already looked at. Now, if we go down to the foot here of Castor, we find the Jellyfish Nebula. And it really does look a bit like a jellyfish, doesn't it? And it's the right way up for once, which is nice. This is another star that exploded, but we're not quite sure when. It was at least 3,000 years ago, so nobody's got any written records of it, but it might have been even longer. It might have been 30,000 years ago when that one blew up. Trying to date these things is a little bit difficult sometimes. And just below it, another nice little object. This one is upside down. This is the Monkey Head Nebula. So spin it round in your mind. The forehead is down here. There's his nose, and the mouth, and the neck is at the top. Try and spin that round, and you really can see a monkey head. And all of those colours there are telling us what the chemical elements are made of. Yeah.
I can see a fish.
You can see a fish. Well, okay.
Blue fish.
Yeah. Right. So that was there. There's one more object in Gemini that I really like, and that's another one of these sun-like stars that's run out of fuel and expired. When little stars like the sun die, they don't blow up as supernovae. They just puff off their outer layers. And this is called the Eskimo Nebula because through a telescope you can kind of see a little face with a fur hood round the outside, caused by these different explosive time zones where it pushes off these layers into space, making these smoke rings in space, really. So that's the Eskimo Nebula, as it's called. And we're just going to now move on to the last constellation, and then I'm going to let you go home. And that is Leo the Lion, which is just rising nicely in the east. And we'll scroll over there, and then you can actually see in the pre-dawn sky a constellation that I just think is a beautiful constellation. It looks just like a lion, and we'll see that in a moment. We'll just let things scroll forward. There's a bit more Milky Way on the bottom diagonal there. So here the Gemini is now sinking down towards the horizon, and we're just going to let that go down and then pivot across. So Mars is heading to behind the tree there. We're just going to go over here, and this is Leo the Lion. Can you see a lion yet? No. Yeah. Can you see it now? How about now? Yeah. I've had some people tell me that there is a lion, but it's the other way round. So, you know, you can make these patterns whatever you want, really. But Leo, when we look in the direction of Leo, we're not looking through the plane of our galaxy. We're looking out into deep space. And so when we do this, we don't see all of the things that you would expect in our galaxy. What we see is lots and lots of other galaxies. And they don't have names. They've all got these catalogue numbers, M something or other. I'm just going to do a little bit of a tour around. Here's one that's got a ring round it. It's probably been formed because one galaxy pushed through the middle of another one, and a great ring of stars has been made as a result. One of those interacting galaxies that Charlotte talked about. Here's three more. They really do look like that through a telescope, even through my little 8-inch reflecting telescope that I built 50 years ago. It's a really lovely thing if you've got a nice dark sky. You do need it to be dark though, because trying to find galaxies which are fairly faint, if there's any light pollution, it really becomes a problem. But I think this is a great way of having a bit of a look round. So there's another group over here, 3 more, look, they're all over the place. And the one at the top there is a very interesting shape indeed. We're going to zoom in on it. The other 2 are little spiral galaxies, but this top one doesn't have an M number. It's even more obscure. Charles Messier didn't put it in his catalogue. And they call this one the hamburger galaxy, because it's like a hamburger with 2 pieces of bread and a chunk of meat through the middle. Of course, the meat is dust and dirt. You wouldn't want to eat it. But we're looking at it very much edge on. So that's the hamburger galaxy. And there are just so many of these in this direction because we've got an unobstructed view straight up out of our galaxy, out into deep space. And perhaps my favourite galaxy of all to look at, because it's really nice and bright, is this one, the Catherine Wheel. And again, you see those centre of the galaxy has stopped forming stars a long time ago now, so all the really bright white and blue ones have burnt out, but the long-lived yellow, orange and red ones in the middle are carrying on. Only where you have new stars forming in the spiral arms, that's where you get the big hot blue ones, but they don't last very long. You have to keep generating new ones all the time. And so with that, I think we're probably at the end of our tour, so I'm going to let the system just run through and head off towards dawn. There's Andromeda again, Virgo, lots of other constellations to look at. We'll look at those another time. But I'll put the lights back on and say thank you very much for listening. And blinded. Is it? Yeah, it's that one. Right, there we go. I'm sorry, I'm very deaf.
Sorry, the toilets.
Toilets. If you go out towards the kitchen, then head that way, and just keep going. You'll find them on your right-hand side, just after the T-junction. Or for the ladies, you go right at the T-junction.